wait for that for a moment. Okay, great, that is working. All right, so now I'm going to start the webinar and we should see people joining.
Hi, everyone. We're just going to give folks a few seconds to pile in. Okay, let's go ahead and get started. Welcome to session 5. I'm Dwayne Watson, and I'll be serving as your session chair. Before we begin, I have a few reminders, and you've heard this a couple of times already. If you have a question for the speaker, you can send it at any time by pressing the Q&A button and entering your question. If your question is selected during the Q&A period, you'll be called upon by name, and I'll be inviting you to unmute. If you prefer that I read your question, just let me know when you write your question. Okay, let's go ahead and get started. It's my pleasure to welcome our first talk by Anita Tobar Enriquez, Hugh Rabagliati, and Holly Brannigan, talking about speakers extrapolate community-level linguistic knowledge from individual linguistic encounters.
Thanks, Joanne. Well, thanks everyone for tuning in. Today I'll be talking about a piece of research in collaboration with Hugh and Holly. That's about how speakers learn community-level linguistic knowledge from individual linguistic encounters. So let's just start with the very big picture here, right? We all know that language use is quite variable. For example, this ordinary object here can be called a potato or spud in the UK, and a patata or papa in Spain. And during dialogue, speakers can also vary their lexical choices. So for example, if you have two Spanish speakers talking about potatoes, they will have to choose between using patata or papa. But how do they make this choice? Well, previous literature suggests that personal linguistic common ground has a lot to do with this, which means that depending on the personal linguistic history that you share with your particular partner, you might change your lexical choices. So, for example, if an interlocutor uses the word papa, then chances are that the speaker will reuse the word that their partner used before, which is a phenomenon known as lexical entrainment in the psycholinguistics of dialogue. And apparently, the effects of personal common ground on speakers' lexical choices are so strong that even when they interact with this partner again, they might maintain the word that they had used before, the word that was in personal common ground. And this phenomenon is known as maintenance of precedence. But why does personal linguistic common ground influence speakers' lexical choices in this way? Well, there are two main approaches or two accounts to explain this. The first one highlights the role of lexical priming, right? And it suggests that speakers reuse their partner's lexical choices during dialogue basically because they had recently processed the word, and this recent processing makes very easy to retrieve the lexical representation of the word from memory, making it very easy to reuse the word, right? And the same applies for maintaining precedence, right? So since the speaker has processed the word twice already, reusing it, it's quite easy. Another explanation, though, highlights the roles of beliefs, of speakers' beliefs about their partner in their lexical choices. So these accounts suggest that the speakers reused lexical choices because they think or they believe that their partner's previous use of the word papa in this case means that their partner prefers this word. So they engage in audience design and decide to use the same word because it makes life easier, basically, right? So they think, well, this partner used this word, so I'm going to use the same word, and this will enhance communication. And of course, these two accounts are not mutually exclusive. They can work together in influencing how speakers make lexical choices during dialogue. But what about community level factors then during dialogue? So far, we've just talked about how personal common ground or interpersonal factors can affect how speakers make lexical choices during dialogue. But in reality, we all know that speakers do not act in isolation. They are all parts of broader linguistic communities which share general patterns of language use. Or in other words, the members of a speech community share communal linguistic common ground depending on their community co-membership. So for example, this subject here, native speakers of Spanish from Spain, they know that it could be called patata or papa, but they're also aware that patata is a preferred term in Spain, right? So they are aware of the community level linguistic preferences, right? So the linguistic preferences of their community. But what happens when a speaker interacts with a partner from another community where they don't really know or they're not sure about the community level preferences of that community, of their partner's community? Are they as likely to entrain to that partner compared to entraining to a partner from their own community? And perhaps perhaps more importantly, how do speakers even learn community level linguistic knowledge in the first place? So to address these issues, we run 3 experiments using participants who were native speakers of different varieties of Spanish. And what we wanted to know was really how speakers learn community preferences during dialogue. And in order to do this, we investigated whether speakers generalize their lexical choices across 2 partners based on their partner's speech communities. So, for example, if a speaker interacts with one partner who is an out community partner, this means a partner from another community, will they generalize the language use to another partner from the same community as their first partner? So to test this, we had participants engage in 2 sessions of a picture naming task, where they took turns with Confederate, which was in pre-programmed software, to first match and then name pictures that appear on the screen, which had both favorite and disfavored names. So in the picture naming task, they first encounter a matching trial. They were asked to match the picture, to select the picture that matched the word papa in this case. So that matched a disfavored name in the participants' community. Which means that basically they experience their partner naming the critical target with a disfavored name. And then in a subsequent naming trial, participants were asked to name the picture that was either on the left or the right, depending on where the target picture appeared, which was randomized. And we measured whether they reused the disfavored name that they had experienced their partner using before, right? So in other words, whether they entrained to this favored use, to this favored name. And we did this with 21 items. And of course, all materials were normed in a sample from the same population of the participants. And we used a spontaneous naming task to identify favored and disfavored names for target pictures, and an acceptability rating task to make sure that these disfavored names were highly acceptable to name the pictures. So in experiment 1, we worked with Spanish speakers from Spain, and they engaged in 2 sessions, right? So in the first session, so something very important here, in each session, they encountered different partners, right? But they encountered the exact same items across sessions. And in session 1, they experienced their partner naming the pictures before them, always using his favorite name, and we measured lexical entrainment. In the second session, they encountered a new partner, and participants were the only ones who actually named the critical targets. So they never experienced their new partner, naming the critical targets, which means that basically the second partner always named fillers. And we measured whether participants maintained entrained terms from the first session, right? So we measured maintenance of entrained disfavored terms. So if participants entrained in session 1, how likely they were to reuse that word or to maintain that word in session 2. And we used a 2x2 between participants design to manipulate participants' beliefs of other partners' communities in each session. So in session 1, participants thought they were interacting with either an in-community partner from Spain, because participants were from Spain, or an out-community partner from Latin America. And in the second session, participants thought they were interacting with either a partner from the same community as the first partner, or from a different community from the first partner. And this is what we found. So, right, so in the first session, we measured lexical entrainment, right? In this graph, the y-axis shows the percentage of use of these favored terms in session 1, while the x-axis shows whether they entrained the first partner's community. In other words, whether they entrained with an in-community partner or an out-community partner in the first session. And the dashed line here shows the baseline of use of these favored terms during the spontaneous naming task that we used to norm the materials, which was about 5%, the mean. And as you can see, participants use these favored terms to a greater extent during the main task compared to the pre-test, suggesting that there was a lexical entrainment effect. However, they entrained almost as often with an in-community partner versus an out-community partner, suggesting that there was no effect of first partner's community on participants' tendency to entrain. In the second session, however, we found that their tendency to maintain these entrained terms was affected by an interaction between the first partner's community and the second partner's community. So in this graph, the y-axis shows the percentage of use, the percentage of maintenance of entrained disfavored terms in session 2, right? So after entraining in session 1, how likely participants were to maintain that entrained term in the second session. The x-axis show whether they entrained with an in-community partner or an out-community partner in the first session, and color-coded you see whether they maintained the word with a partner from the same community as the first partner in the first session, or a different community in the second session, or a partner from a different community from the first partner in the second session. And we found a significant interaction between these two variables, right? So here we can see that when participants entrained to an out-community partner in the first session, they were more likely to maintain that word with another out-community partner versus an in-community partner in the second session, which basically means that when participants entrained to an out-community partner in session 1, they generalized that word to other out-community partners from the same community as the first partner, but they didn't to a greater extent than compared to in-community partners here. However, when they entrained to an in-community partner in the first session, they were not as more likely to generalize that word to another in-community partner versus an out-community partner. So to wrap up very quickly, there was no effect on entrainment. There was an entrainment effect, but no effect on entrainment. But there was an effect of partners' communities on maintenance. And in particular, there was a significant interaction between these two variables. However, we wanted to know whether these effects of speech community on speakers' lexical choices would generalize to other speech communities. So with that in mind, we ran experiment 2, which was basically the same thing as experiment 1, but with a different population. So instead of working with people from Spain, we recruited Mexican speakers. And again, they engaged in 2 sessions. We measured lexical entrainment in session 1, maintenance of entrained terms in session 2, and we manipulated their beliefs about their partners' communities. So in the first session, they thought they were interacting with either an in-community partner from Mexico this time, because our participants were from Mexico, or with an out-community partner from Argentina. And in the second session, they thought they were interacting with a partner from the same community as the first partner or not. And long story short, we found the same pattern of results. Right? So we again found a lexical entrainment effect, but there was no significant difference between participants' tendency to entrain to an in-community partner versus an out-community partner. And we found, again, a significant interaction between first partner's community and second partner's community on participants' tendency to maintain an entrained term in the second session. So again, what happened here was that participants, when participants entrained to an out-community partner in the first session, they were more likely to generalize that word to out-community partners versus from the same community versus in-community partners. But when they entrained to an in-community partner in the first session, they were not more likely to generalize that word to another in-community partner versus an out-community partner. So there was no effect on entrainment, there was an effect on maintenance, there was a significant interaction again, which suggests that the effects and non-effects of speech community on speakers' lexical choices generalize across communities. However, I have to mention that there was a potential confounding variable here, right? Which was the linguistic status of the out communities, speech, like the out communities that we were working with, right? And this is important because previous research suggests that the social status of your partner can affect your tendency to entrain to them, and by extension here, to maintain an entrained word.
You have 5 minutes.
Thank you. And also recent research suggests that in certain cases, speakers from Spain might perceive certain Latin American varieties as lower status compared to the Spanish variety of Spanish. And the same happens with Mexican speakers compared to Argentinian, right, to the Argentinian variety of Spanish. So it could be the case that participants didn't train more or less with our community partners because of this difference, this potential perceived difference in linguistic status. So to rule that out, we ran experiment 3. So in this experiment, we recruited Mexican participants, and we had them go through the same thing, the roughly same paradigm, but we manipulated their beliefs about their partners' community status. So in the first session, participants thought that they were interacting with either a high status out community partner from Spain or a low status out community partner from Argentina. And in the second session, all participants thought they were interacting with a middle status in community partner from Mexico, because we wanted to make sure that participants' tendency to generalize our community terms to in-community partners was not affected by linguistic status either. And spoiler alert, we didn't find anything indicating that. So again, we found a lexical entrainment effect, but there was no difference between conditions. And there was no difference between conditions as well in their tendency to maintain and train these favored terms, which means basically that study 1 and study 2 results reflect speech community effects and non-linguistic status effects, at least in these experiments. So to sum up very quickly, lexical entrainment is not affected by beliefs about partner speech community. However, maintenance is affected by the second partner's relative speech community, which in turn suggests that information about partner's community must have been encoded during entrainment, right? So even though participants' beliefs about their partners did not affect their behavior, this information was encoded during language production.
2 minutes.
And speakers extrapolate community level information based on their beliefs about their partner's speech community and their own perceived knowledge of community norms, right? So we found that participants, when they interacted with an out community partner in the first session, they generalized their language use to other out community partners based on their beliefs. But this did not happen when they interacted with an in-community partner, presumably because of their previous experience with other in-community partners, right? So since they had lots of experience with in-community partners, this recent interaction with an in-community partner did not update their knowledge of their own community norms or views to the extent to alter their behavior. So the take-home message here is that the speakers extrapolate community-level information from individual linguistic encounters based on their beliefs about their partner's community-level preferences, opening new directions to understand the cognitive mechanisms involved in the creation of community-level knowledge and how they may vary across the lifespan. And I'm very excited to tell you guys that this paper was very recently accepted for publication recognition. So if you want to know more about this, I'm very happy to share it with you. And that's everything from me.
All right. Thank you very much, Anita, for a great talk. We have quite a few questions in the Q&A. And before I select, I think I'm going to select Scott Fraundorf first. And while he's being unmuted, I'll just remind folks to put their question in the Q&A. And if you're a student or early career person, please indicate that.
So should I stop sharing my screen so I can see you guys again? Okay.
Sure.
Cool.
So Scott Fraundorf.
All right. Thank you so much for the really interesting and exciting work. I really enjoyed the talk. I think it's really exciting results. In experiment 3, where you found the null effect or the no difference between the two different varieties of out community Spanish, do you know if the participants in that study, in fact, viewed those two varieties as different in prestige? I mean, they might in general, but do you know if those participants actually perceive that difference?
No, we didn't really test that in particular. Nope.
Okay.
But we're thinking about it. I mean, it's a very interesting route to pursue. Absolutely.
Thank you. I will check out your paper.
Great, thanks.
All right, so I'm going to read the next question by Therese Grutter. Would you have any predictions about what you would see if the partner was a non-native speaker of the language, so someone with an English accent or a Spanish accent?
Well, I mean, I love to see that. I love to see that that study. I think it's difficult to tell, right? Because my intuition is that with non-native speakers, with a non-native speaker, you might think that there's way more variation between non-native speakers than between just members of the same speech community who share norms. You know, like all native speakers have different journeys, I guess. So I think I wouldn't think that this would generalize to that kind of population as well. But the honest answer is that I don't know, and I would love to see that.
All right, well, our next question is by Savitri Nambudirapad. And we'll wait a second for her to be unmuted, or him.
Hi, thank you so much for a great talk and congrats on the publication. So I'm curious if you think there might be, or I'm curious more about like the mechanism or what the speaker's knowledge, what type of knowledge the speakers might be using. So do you think there might be different results based on participants' knowledge, and it might be like accurate or non-accurate knowledge about particular linguistic features of the outgroup variety? So if they know something about like papa versus patata or whatever the other words are. So can you, I don't know if that made sense, but can you talk a little bit about that?
Yes. Well, so in this particular case, we normed the materials in the participants' population, right? So we were not actually using out community norms during the experiment. I hope that was clear from the talk. And we decided to do that because we didn't want to have to deal with potential differences in the degree of knowledge between participants, their knowledge about the out community norms, right? Because there was not really a way to control that. Because then if you ask them, then you prime them, right? So yeah, I mean, I absolutely think that previous knowledge can affect your tendency to generalize or to learn community level norms, of course. But that's how we tried to kind of avoid that question in this particular study. I'm not sure if I'm answering your questions.
Yeah, thank you.
Yeah.
You can ask after maybe in another study. But yeah, I think that that's really exciting. Thank you so much.
Yeah, thanks.
All right, our next question is going to come from Jesse Snedeker.
The host muted me again. Stop doing that, Dwayne. One of the things I was trying to make sense of for myself is why it was that you were getting so much generalization, right, of the entrained material later on. You were really focused on the fact that it was different, but actually it was really quite high across the board. So maybe it was more that they overgeneralizing. And one of the things I found myself thinking about is whether your manipulation of beliefs about partners had actually been effective, particularly in the context where it's an in-group partner. If I have an in-group partner and they repeatedly violate the lexical conventions of my language, I might lose faith that it's an in-group partner, particularly if I know that I'm in an experiment. Did you do a validity check on that at all?
Yes. So we did. Thanks for the question, though. I mean, that's an interesting thing to keep in mind. Yes. So by the end of each experiment, we asked participants how many people they had played with and where were they from, right? Because we wanted to make sure that they didn't realize that they played with a computer first, of course, because then the answers are not valid anymore. And that they actually believe that they were playing with the people that we actually want them to believe they were playing with. And that was really effective. So just about, I don't know, I mean, I think that we had to exclude about 5 participants per experiment or something like that. So at least they reported that they believed the manipulation, right?
I do feel like framing on that question matters a lot. I could either take it as a test of my memory. You're asking me, do I remember who you told me I played with? Or depending on how you ask, I could take it like, did you believe me when I said that, right? I feel like you almost have to mark the belief in order to get people to tell you what they really thought, or how confident are you that what I told you was true?
Yeah, but I think that, I mean, if we do that, then we risk that they realize by the very end of the task that they didn't play with a real person, and then they say, well, like in retrospective, I realized I played with a computer or something like that, I think, I mean, I honestly think this is it's a tricky one, right?
I think you should expect a difference, though. The interesting part would be a difference between whether it was in-group or out-group. But I'll let the next person continue. Thank you so much.
Yeah, no worries. Thank you for your question.
All right, we have time for one last question by Zachary Kevin Maher.
Hi, thanks for can you hear me?
Yeah.
So my question is kind of going along the lines of the previous questions. So I'll just ask, I'm wondering how much in a real world environment participants are just people are making really the opposite inference from what you're showing here, which is based on the forms that I'm hearing, what speech community does my interlocutor belong to? I'm wondering if you're worried that this is occurring, and I think this is pretty related to Jesse's question. To what extent is that interacting with your task here? So, right, you use a form, this form indexes membership in a particular speech community, and because this form indexes that, I know whether you're part of my in-group or out-group.
Well, I'm not sure if I'm actually getting your question, because in this case, so in both conditions, participants saw the exact same words. So,
but they're also here. They're also receiving this information about what speech community
yes.
The individual in the vignette ostensibly belongs to. And I'm just wondering if. So, I mean, one question the question could be narrowly about your task, or the question could be more broadly about the hypothesis space. And perhaps I'm more interested in having you speculate about the latter. In a typical interaction with someone from an out group, there's potential for both the forms to indicate the group membership of your interlocutor, and there's the potential for the forms your interlocutor uses to teach you something about their language. And your level of knowledge, so this is going back to the other questions, if you have knowledge about the outgroup's language, then maybe you're not needing to update it, but if and maybe instead you're using that information to determine the speaker's language.
Yes. Well, I mean, I think that in this case, we were interested in how explicit beliefs about a partner's community could affect their lexical choices and their tendency to generalize words, right? So of course that in real life, face-to-face interaction or even online interaction with a real person who can actually show community membership in other ways, accent or whatever, things wouldn't be exactly the same way, but we wanted to work with a very controlled paradigm because we were actually interested in isolating the beliefs of the speakers about community. And I think that we kind of, we did show that beliefs on their own can influence behavior.
Okay, well, with that, I think we will need to wrap this talk up. Let's virtually thank Anita, and let's get started on our second talk in the session. So our next talk will be Interference in the Comprehension of Filler Gap and Filler Resumptive Dependencies by Nikki Kosterich, Mayan Keshev, Daria Shamai, and Aya Meltzer-Asher.
Okay, so hi everyone, and thanks so much for joining. So I think we could just dive right in. So sentence processing is thought to involve encoding items in memory and then retrieving them for successful interpretation. And it's been proposed that items are stored in a content addressable manner. According to queue-based retrieval, which is a prominent theory for sentence comprehension, these items are encoded with features that are later used as cues for retrieval. Importantly, though, queue-based retrieval is subject to similarity-based interference, which is interference that's caused by elements in memory that share the same featural specification of a given target. Similarity-based interference effects have been largely attributed to retrieval interference. So, for example, in the following sentence, the designers who the authors met today enjoy reading. The matrix clause subject, the designers, and the relative clause subject, the authors, are specified for some features. For instance, they're both animate in subject position and plural. As can be seen, the two noun phrases share their feature specification. Furthermore, the main verb enjoy, which is the retrieval site for the matrix clause subject, is specified for some features as well. So it requires an animate plural subject. And these features are the retrieval cues it uses to search for a matching item in memory that can be integrated as its subject, in our case, the noun phrase, the designers. However, since the verbs retrieval cues match more than one item in memory, some form of retrieval difficulty or even misretrieval is expected. Crucially, only features that are specified at the retrieval site, which in our case is all three features, are retrieval cues and are predicted to cause retrieval interference. A second source that's been suggested as the culprit of similarity interference is encoding interference, namely degraded memory representations of two noun phrases that overlap in their feature specification already at encoding, so prior to retrieval. So to illustrate this, a similar example to the previous one is shown where the two noun phrases, the designers and the authors, are specified for some features. As before, they match on the stated features. But a crucial difference here is that the verb enjoyed in the past tense is not specified for number. That is, number is not a retrieval cue. But encoding interference is predicted even when the overlapping features are not relevant for retrieval, but rather simply because the memory representations of the two items are not distinguishable enough. One recent study showing this effect is the first example in Villada et al. 2018, where they used Italian relative clauses manipulating the object's gender to be either masculine or feminine, and the subject of the relative clause's gender to match or mismatch that of the objects. The relative clause verbs were past participles that don't agree in gender with the subject. So in this way, they manipulated the similarity between the two noun phrases in the sentence, but not in a way that's relevant for retrieval. They found interference in gender match conditions manifested in both lower accuracy rates and in increased reading times on the verb. Some additional observations of encoding interference in online and offline measures can be seen in the table. But what's interesting is that, as can be seen in the two rightmost columns, even when interference was not found in online measures, effects of lower accuracy comprehension are detected in offline measures. So just to summarize, interference at retrieval versus at encoding are distinct in the following way. When the target and the distractor share some feature that's relevant at retrieval, retrieval interference is expected. Encoding interference is also predicted in this case, but in cases where the relevant overlapping feature is not a retrieval cue, if interference is detected, it can only be attributed to encoding difficulty. So in the current study, we tested for similarity-based interference in Hebrew object relative clauses, taking advantage of the fact that gender in Hebrew is morphologically marked on nouns, verbs, and crucially on pronouns, which includes resumptive pronouns. Resumptive pronouns are pronouns that appear at the tail of a filler gap dependency, and importantly, they're grammatical in Hebrew. Relevant to our purposes, they're obligatory in indirect object relative clauses and optional in direct object relative clauses. So this allowed us to test whether a distractor, which matches the filler and gender, would cause interference both when gender is a retrieval cue, so in filler resumptive dependencies, and when gender is not a retrieval cue, so in filler gap dependencies. A previous study in our lab found a facilitatory interference effect using a self-paced reading task. So we used Hebrew relative clauses with obligatory resumption, and we manipulated first the filler's gender to either match or mismatch that of the resumptive pronoun's gender. This rendered the sentence either grammatical or ungrammatical. And the second manipulation was of the distractor's gender to either match or mismatch that of the filler's. So faster reading times were detected at the retrieval site in ungrammatical match conditions, namely when the distractor matched the ungrammatical resumptive pronoun. This was as compared to ungrammatical mismatch conditions. But interestingly, we didn't find retrieval interference in the grammatical sentences, which raised the question of what comprehenders actually understand when parsing the grammatical match sentences, where the resumptive has two matching antecedents. So at this point, Mayan will talk to you about our new experiments.
So for the current study, we're focusing on grammatical dependencies with comprehension accuracy. And in the first experiment, we'll look again at relative clauses that end with resumptive pronouns, where again, interference can arise either from encoding or retrieval interference. And therefore, we use the environment where resumption is obligatory in Hebrew, that is in the indirect prepositional object position. And so let's have a look at an example from the study. So in this relative clause, the cashier that the customers listened to her, הקופאית שהלקוחות הקשיבו לה, we have a resumptive pronoun which triggers the retrieval of the filler. And to create interference, we manipulate the gender of another noun at the subject position of the main clause. So the distractor could either mismatch or match the gender marking of the filler and the resumptive pronoun. And we expect to see interference in that second case where the distractor matches the target and the retrieval cue. In principle, this could interfere with the encoding of the filler's features or with cue-based retrieval at the pronoun site. So we present these sentences word by word at a rate of 400 milliseconds, and we examine participants' comprehension with yes-no questions. To do this, we use two types of questions. One asking whether the filler was the object of the relative clause, where the answer should be yes, and one asking whether distractor was that object, where the correct answer is no. If interference affects offline comprehension, it should be reflected in increased error rate for these distractor questions. So participants are more likely to provide incorrect yes responses here than incorrect no responses in filler questions, since people usually have a general bias for responding yes. So overall, we have 4 all grammatical conditions manipulating the distractor's gender marking, match or mismatch, and the question type targeting the filler or the distractor. And we aim to see interference effect in misinterpretation rate. So let's look at the results. Here we can see the accuracy rate in the mismatch condition. So you can see that accuracy is relatively high for both types of questions. But in match conditions, accuracy drops significantly for distractor questions. And this results in main effects of distractor and question type, as well as a significant interaction. So readers mistake the distractor to be the object of the relative clause, that is, the antecedent of the resumptive pronoun, when the distractor's gender is the same as the filler and the pronouns. To look at how people discriminate between filler and distractors, above and beyond the general yes bias, we also examined participants' responses using an ROC analysis. So in this analysis, we'll look at the participants' yes and no responses in both question types, but we part these responses by the confidence ratings that participants provided for each trial. And this creates this kind of a scale between certainly yes and certainly no. And for each response plus confidence pairing, we will plot its proportion out of all correct responses on the y-axis and the proportion out of all incorrect responses on the x-axis. So let's start, for example, with the mismatch condition. So we start with yes responses with high confidence ratings. These constitute about 65% out of all correct responses, but less than 10% out of incorrect responses. Now we add to that yes responses with medium confidence ratings. Now we cover a higher percentage on both axes, and we go on to add the last level of yes responses and continue to no responses in the order indicated by the scale. That way, we create the full curve that compares correct and incorrect responses. And this should exhibit how participants discriminate the distractor from the filler on the comprehension questions. If participants are guessing, the response curve should align with this dashed gray line, which represents a linear increase in correct and incorrect responses. So the blue line exhibits high discriminability, and the dashed line represents no discriminability. Now, to distinguish the performance in different conditions, we use the measure of area under the curve. And for the dashed line, this should be 0.5. And this should get closer to 1 as performance improves. In trials with mismatching distractor, where we're not expecting interference, the area under the curve is relatively large. But in the match conditions, we see decreased discriminability. So in line with the simple accuracy analysis, we see here that the gender matching distractor disrupts comprehension. So overall, we observe similarity-based interference in object relatives, which are resolved with a grammatical resumptive pronoun, where gender is a retrieval cue. Next, for the second experiment, we wanted to check whether this finding extends to relative clauses with gap resolutions. So in this case, the gender of the filler is not marked at the retrieval site. So to do this, experiment 2 added another factor to the manipulation. As in the previous experiment, we have the distractor match-mismatch manipulation and the 2 different question types, but we now also manipulate the dependency to either resolve with a gap or with a resumptive pronoun. And to create this design, we moved to an environment where resumptive pronouns are optional in Hebrew, that is, using direct object positions. So here's an example for the construction of the material. This is the same design as we previously had. We just switched the verbs to take a direct object, and we add the gap conditions. And this way, we're hoping to distinguish between retrieval interference and encoding interference. So if misinterpretations are associated with having that gender cue at the retrieval site, which then accidentally triggers retrieval of the distractor, we should see interference effects only in the resumptive conditions. However, if the shared gender feature makes the distractor and the filler more confusable already at encoding, misinterpretation should arise also in gap conditions. So let's look at the results. The accuracy pattern in the resumptive conditions replicates what we found in experiment 1. And interestingly, so do the results in the gap condition. So we observe the same pattern where readers have low accuracy when they're asked whether a gender matching distractor was the antecedent for the resumptive pronoun or the object gap. And our C analysis similarly exhibits a significant contrast in discriminability between the match and mismatch conditions. These curves are for the resumptive pronoun conditions, and that means the decrease in discriminability here should reflect the effects of both encoding interference and retrieval interference. Now, in the gap conditions, we also see a significant decrease in discriminability, which now represents only encoding interference. So the difference between the 2 blue lines represents the maximal contribution of retrieval interference to the misinterpretations. And this is a rather modest contribution relatively to that associated with the encoding interference. Moreover, it's likely to be an overestimate. So notice that the conditions where interference is predicted perfectly line up. We see the same discriminability level in the pink lines representing the match conditions for both gap and resumptive resolutions. So it's not clear that the shaded gray area reflects the interference due to multiple matched for the gender cue. It could also just reflect contribution of having a retrieval cue with a single match over not having a cue at all. So overall, we've seen that a gender matching distractor can interfere with the comprehension of Hebrew object relatives. And this happens both when gender is used at the retrieval as a cue and when it is not. And we failed to detect a clear difference between interference in gap and pronoun resolutions, which means that encoding interference seems to be mostly sufficient to account for the similarity-based interference we detect here. So having found evidence for encoding but not retrieval interference, we wanted to look into misinterpretations in more detail. We wanted to check whether this misinterpretation pattern is unique to tasks that require low engagement of participants, as yes/no questions do. And we also wanted to get more information as to how the nouns are represented in readers' memory. So we used the same materials as in experiment 2, and that is along with the match-mismatch manipulation and the retrieval site manipulation, but this time we ask different comprehension questions. We use questions that require a more detailed response. So instead of providing a noun for the participants and asking them to accept or reject it as the object of the relative clause, we now ask them who was that object and had them choose between 4 options: the filler, bearing the correct agreement or incorrect gender marking, and the distractor, again, either it appeared in the sentence or bearing incorrect gender marking. Now, we're only 2/3 of the way in running this, so we don't want to read too much into the results, but just to observe the general patterns for now. Here you can see the proportions with which participants chose each of the options on the different conditions. They managed to correctly identify the filler most of the time, and this is shown in the lighter blue bars. It's currently not clear if this accuracy rate is affected by the manipulation. However, in the bright pink bars, you can see the rate of accidentally retrieving the distractor as is without a feature modification. And this varies considerably between the conditions. Specifically, the distractor's features get more malleable when they mismatch those of the filler. So the representation of agreement is more malleable when the distractor and the filler mismatch. Overall, the current study reveals that people often misinterpret simple relative clauses, and they misidentify the filler noun when there's a noun of the same gender in the sentence, at least in some tasks. And currently, we also don't see differences between gap and pronoun resolutions. And that means that we don't see a difference between interference with gender cues and without ones at the retrieval site. And this provides evidence for encoding interference, which supports previous observations of this kind of interference and suggests that it can be detected not only in slow reading times, but also in misinterpretation rates. And moreover, it's interesting to know that in our experiment, we detect these interference effects, even though the filler appears after the distractor and after the distractor's dependencies are complete. So readers don't have to retrieve the distractor within or at any point after the relative clause. So this could give rise to interesting future studies, testing if the magnitude of these interference effects is modulated by the position of the distractor, the overlap in other features, and the nature of the gender feature, using grammatical gender on inanimate nouns rather than gender associated with human reference, as we did here. That's all we got for today. Thank you.
All right, thank you, Mayan and Nikki. Let's open things up for questions. Our first question is by Mary Ellen McDonald. Mary Ellen, someone will be unmuting you soon.
Really, really interesting talk. Thank you. I want to ask about where the interference is, not just in encoding versus retrieval, but whether it is in the mind of the comprehender versus the mind of the speakers who create the statistics. Because as we know, object relatives, at least, are very sensitive to similarity of the NPs in speakers' productions. The more similar those two entities are, the more people avoid object relatives in 6 or 8 languages that I know production work about. So the similarity-based interference is confounded with rarity of that structure with those kinds of entities. And so one explanation is interference is all in production, and what you see in comprehension is costs of encountering rare things, but not interference. The alternative is it's all in the comprehender in the way that you've sketched out. And a third possibility, because they're not mutually exclusive, is that we can see effects of both. Thanks.
So thank you for this question. It's very interesting. We haven't, as you mentioned, we framed it as comprehension effects, and we haven't thought about the production side of it. But yeah, I agree, these are not mutually exclusive. I think that for the first 2 experiments, participants really get to like chance level on the distractor questions. And if it's just about frequency, I think maybe I would have expected that effect not to be so great. Like people would be worse a bit, but not at chance level on distractor questions. So like my intuition would be to say that there is comprehension there as well, but I think that could be a very interesting thing to continue checking how that like corresponds to production, and if we can manage to find a manipulation to disentangle it and find out whether the reduced accuracy rates are a contribution of both production frequencies and comprehension mechanisms. Yeah, thank you.
All right, our next question will be asked by Gail Mauner. Gail has a question about Beyonce.
Hi. Whoops, let me do one thing here. Okay, I'm hearing myself twice because I've got 2 devices going on. But here's the question. When we encounter sentences like filler gap sentences or relative clauses in real life contexts, we generally know a lot more about who and what we're talking about than just the manager and the cashier. Yeah, I mean, we have much more enriched representations. And so, when we get these sentences and experiments that are out of the blue, they're really stripped down and we're forced to just use very unenriched cues for memory and for encoding. And so I'm wondering if you used rigid designators like Beyonce, Billie Eilish, Trump, Biden, Netanyahu, things where we have very strong representations, and yet you can still manipulate, the gender cues and whatever. Do you think you're going to get the same kinds of effects that you're getting now? Or alternatively, using one rigid designator and one common noun, or using contexts in which you've enriched. We already know a lot about the cashier. We already know a lot about the manager. Do you still think you're going to get these interference effects? That is, what are we learning about everyday language?
Right. Yeah, so you're right. We're kind of pushing people to the extreme with these manipulations. So it's rapid presentation, it's out of context. Those are nouns that are very similar so they're both animate, it's not just the gender, they're both animate, they're usually of the same like semantic field. Yes. I obviously don't know what we would find for different circumstances. I think that for the context, either provided like before the sentence or have using reference from the real world, I'm guessing that would help. But I'm I also feel that what we are learning, even in these very unnatural circumstances, could tell us things about how the parsing mechanisms operate. So most of the time we don't hear things out of context, but occasionally we do. We hear a conversation as we walk by, or we join a conversation that's already going on. So I hope these paradigms, although they're very unnatural, can tell us something about the underlying memory mechanisms that we use.
Yeah, I would encourage you to follow this up so that we have some sense of, you know, how flexible we are, or, you know, how much of this is about memory and how much of this is about language.
Yeah, definitely. That's part of why we started the third experiment. So we thought maybe it's something about the task, and after we finished that, yes, it would be a great idea to try and enrich the context.
Great.
Thank you.
Thank you.
All right. I think we have a couple of more questions, but we are out of time for this talk. So let's all thank Mayan and Nikki for a great talk. And we're going to move to our next talk. And if you, just as a reminder, if you do have questions, you can move them to the discussion board after the session. All right, our last talk of the session is going to be manipulating difficulty at different levels of language production elicits distinct patterns of disfluency by Arielle Pistono and Rob Hartziger.
Hi, can you hear me? No? Am I muted still?
Yes, we can hear you.
Ah, great. Okay, let's talk about disfluencies. And this is work really led by Arielle Pistono, who's a postdoc in my lab. And in her postdoc is interested in trying to pinpoint the level in the language production system at which different disfluencies occur. But before we start, let's first ask ourselves what we mean with disfluencies in speech. So disfluencies are typically defined as phenomena that interrupts the flow of speech and do not add propositional content to an utterance. This is Foxtree and colleagues in 1995. So these are filled pauses, silent pauses, self-corrections, repetitions, and so on. Disfluencies are really frequent, so you have about 6 disfluencies per 100 words. But we don't really understand where they come from. So we have great psycholinguistic models of language production that can account for reaction times or speech error patterns, but none of them, as far as we are aware, really take into account disfluency. Now, a number of authors have suggested that some disfluencies can be pinpointed at particular levels in the language production system, conceptualized as a sequence of processing stages. For instance, the lexical selection level, the conceptual generation level, or the level of self-monitoring the utterances. And many of these studies have used the task you see over here, the network task, in which people describe a network of pictures that differ in particular features that you want to manipulate, so that you can incur difficulty at one particular level of production while keeping other levels of production constant. So in this talk, we addressed 2 questions. On the one hand, we did 2 experiments to find out which disfluency patterns occur when lexical selection becomes difficult. and when grammatical selection becomes difficult and conceptual formulation becomes a problem. And mind you, with grammatical selection, I mean the selection of function words, in particular, the selection of Dutch determiners that are marked for gender. And here we did classical network task experiments, which we analyzed with linear mixed effects models. The second question turns it around in the sense that we now want to predict the type of this difficulty a person is experiencing. So is there difficulty at the level of lexical selection, grammatical selection, and so on the basis of the pattern of this fluency? And to answer this reversed question, we use multivariate pattern analysis. And we'll get to that a bit later. The task we use in all of our experiments is the one you see over here. So we begin with a fixation cross for a while. Then you see the network for 2 minutes, allowing visual inspection. And then at one point, a red point marker appears and starts to move throughout this network at a particular pace. The instruction for the participant is to describe the network, including all the objects and all the paths that the little dot is taking, and to do so in synchrony with the dot using complete sentences. And then you get utterances like the one you see over here. Then the dot goes up through a small arc to the left to the basket. We also monitored eye movements during this task to control for the fluencies that were not related to word preparation difficulties. I don't have time to present those eye tracking data, but if you want to, we can discuss them in the question and answer session. Okay, and then one more thing to mention about the task is that, first of all, we looked at disfluencies only that were related to the picture's name. So these were the disfluencies that were related to the variables we manipulated, namely whether the picture is difficult to name or not. So typically we looked at prepositional phrases like to the boat. We looked at a number of types of disfluencies like self-corrections, filled pauses, silent pauses, prolongations, and repetitions. I'll just let you read the examples for yourself. Note, however, that we did the experiment in Dutch with Dutch subjects. So these are English translations of the Dutch original examples. So in experiment 1, we manipulated difficulties at the level of lexical selection and its grammatical selection. And to manipulate lexical selection difficulties, we played around with name agreement. So we had items that had low name agreement, where you have multiple names, like in English. In Dutch, you can say ship and boat. And then we had pictures with high name agreement, like leaf, which also in Dutch is only one word. Each network had 4 low agreement items and 4 high agreement items. Then we manipulated grammatical gender. Dutch has 2 genders, common gender and neuter gender. The common gender determiner is de, and the neuter gender determiner is het. And one thing to remember is that common gender is more common in Dutch, it's more frequent. So what we're looking at here is actually an effect of frequency of these determiners. We believe that neuter gender, because the determiner is less frequent, it would be more difficult to produce. So 4 items had common gender, 4 had neuter gender, and we matched the pictures for a number of variables, including frequency, age of acquisition, and number of names for the most dominant name. Okay. We predicted that lexical selection difficulty, as operationalized here by using name agreement, would lead to pauses and self-corrections, more of them as compared to high name agreement. And this will be consistent with our earlier study from 2010. Furthermore, we predicted that grammatical selection difficulty, in effect, less frequent neuter gender as compared to more frequent common gender, would also induce disfluency. And we tested this in 20 Dutch participants using 20 networks, each consisting of 8 objects. And here are the results. Note first that we get quite a large number of disfluencies in this paradigm. So 16.3% of the pictures induced at least one disfluency. Let's look at the distribution then of the disfluencies as a function of name agreements. As you can see here, the low name agreement items elicited much more disfluencies than the high name agreement condition as predicted. We also found an effect of gender. Common gender items elicited more disfluencies than neuter gender items, and this was particularly the case in the low name agreement condition. The interaction was significant. Note that the gender effect is opposite from what we predicted. So more disfluencies for the more frequent, namely common gender items. If you look at all the disfluencies by themselves, then we find name agreement effects on self-corrections, on silent pauses, and on filled pauses. So they occur more often if a name agreement is smaller. We found a gender effect for prolongations. So it's really the prolongations that are driving the gender effect overall, it seems. More prolongations with common gender. So what have we got here then? So pictures with low name agreement led to more self-corrections, more silent pauses, more filled pauses. This replicates our earlier study, and one interpretation you could give is that pauses can be seen as an act of choice between two items with similar semantic properties, as Beattie and Butterworth called it in 1979. Because of this act of choice, or perhaps you could call it competition between lexical competitors, you get pauses, but you also get more errors, leading to self-corrections of those errors. Opposite from our predictions, we found more prolongations before common gender items. And there's two possible explanations we have for this. One of them is that common gender is more frequent in Dutch, but in our experiment, because we explicitly manipulated this, the distribution was quite different from that in the language, namely 50-50. So one possibility is that our participants over-predicted low frequent neuter gender because it occurred relatively frequent in our experiment. Another possibility is that this has to do something with the phonological form of the common gender determiner. De lends itself quite well for prolongation. You can say de, but het, the neuter gender determiner, does not lend itself well for prolongation because it ends with a stop consonant. So you cannot prolongate het. Let's quickly go to the next experiment, where the aim was to cause difficulty at the level of conceptualization. So we move up in the language production system. It's difficult to affect conceptualization directly. So what we did was a sort of manipulation by proxy, make it more difficult to do a step before it, namely visual processing of the items. This is why you see blurred items and clear items in this example. So if you blur the items, you make visual object recognition more difficult, and hence you delay conceptualization. Before we did this experiment, however, we first did a control experiment to choose the right level of blurring. And in that control experiment, we presented stimuli like the ones you see over here with no blurring, a radius of 2 pixels blurring, 4 pixel blurring, or 6 pixel blurring. And we looked at the speed and accuracy with which people named these items and observed that with 4 pixels, people had a significant and quite considerable delay in naming latencies, although the accuracy of naming was relatively comparable to that in the control condition. So that seemed like a good level of blurring for our experiments. Then in the experiments, we presented 4 blurred items and 4 clear items in each network. And we predicted that conceptual formulation difficulty as operationalized in this way would induce more disfluencies, like Schnet and Corley in fact found in an earlier study in English. We had 20 Dutch participants again and 20 networks. And so what are the results? Well, if I can paraphrase Jerry Altman years ago, who said, do you expect me to come all the way to the east coast of the US to show you some null results? And then he showed some null results. I'm afraid I'm going to paraphrase Jerry and say, there are null results, unfortunately, of blurring. There's no effect of blurring on disfluencies overall. And then when we look at individual types of disfluencies, none of them showed an effect of blurring. What is interesting to note is that we had a much larger number of disfluencies overall across the board in this experiment. So what's going on here? So to our surprise, impeding conceptual access by doing this visual manipulation did not elicit more disfluencies. And there's a couple of ideas we have that might be going on here. So first of all, we had a lot of disfluencies in this experiment, much more than in experiment 1. Perhaps this is because the visually salient manipulation of blurring increased task difficulty overall. So we made the experiment as a whole a lot more difficult. You have lots of difficult items, and this led to more disfluency in all conditions. It's also possible that the problem is specific to the blurred items. Note that an interesting difference between this experiment and experiment 1 is that in experiment 1, you had a subtle implicit manipulation like name agreements. Blurriness is really in your face, right? It's something that's very visually salient. So perhaps this allows participants to anticipate that a difficult item will come up, be ready for it, and then as a result, preempt, let's say, the difficulty. The third possibility is that our manipulation was not the best manipulation, and perhaps we should have had even more blurring. So any suggestions are really welcome. So let's move for the next 5 minutes or so to the second question, which is, can we turn it around? So if I give you a bunch of disfluencies a particular speaker produces, can I then predict whether that person is naming low name agreement items or high name agreement items? Can we predict a condition on the basis of the pattern of disfluencies that they produce? And for that, we use multivariate pattern analysis, as you see over here on the slide. So when we use a classical univariate analysis, we focus on each dimension or variable, and we compare whether two conditions differ. The distribution of one dimension doesn't depend on other dimensions. But in a multivariate pattern analysis, all dimensions are taken into account at the same time. You try in this high dimensional space to find the angle, as it were, that distinguishes different conditions from each other. So we trained a classifier to predict whether people were mentioning low name agreement items or high name agreement items, common or neuter gender items, blurry or non-blurry items, on the basis of their individual patterns of disfluencies. So the classifier creates a solution, a prediction for each participant individually, giving particular weights to the features we put in there. So those are different disfluency types. And then you can also look at whether this is consistent across participants. So is it the case that different participants show similar patterns or combinations of these features? And let's have a quick look. So here are the MVPA results for name agreement. So what you can see first of all is that the classifier managed to predict the condition way above chance level. So almost 60% of the trials could be predicted correctly by the classifier. And we also found that all 4 of these disfluency types, self-correction, silent pauses, prolongations, and filled pauses, were consistent features across participants. So this is nice additional information, let's say, to the LME analysis we did before. If you do the MVPA on gender, then we find it's not shown here on the slide, but we also predict gender condition above chance, albeit very slightly. So now we're talking about 53% of the trials. Importantly, if you look at the different types of disfluencies, then you see that only one of them is consistent across participants, which is prolongations. So this reinforces our earlier conclusion that it's really the prolongations that drive the gender effect over here. And it does so consistently across different participants. Then let's move to the blurry items. Can the MVPA predict whether you're naming a blurry item or a non-blurry item? You might think, well, no way, because you showed all these null results before. In fact, the classifier does manage to classify whether you're naming blurry or a non-blurry item above chance, although very, very slightly above chance, 53.24%, significantly so. But interestingly enough, none of the 4 disfluency types here was a consistence predictor across participants, suggesting even though the pattern of disfluencies for each participant has information about whether the person is naming a blurry or a non-blurry item, those patterns are not identical for different participants. They have a variation in ways in which the blurriness effect reflects itself in their disfluencies. And that's getting us to the conclusions here. So the MVPA results from experiment 1 show that fluency patterns are informative about particular linguistic difficulties. The classifier could learn and predict name agreements and gender based on disfluency data. And these features were stable across participants. The MVPA in experiment 2 provided complementary findings to our earlier LME analysis, in the sense that it showed that, perhaps unexpected, but the algorithm shows that there is information present in the disfluency patterns that the classifier can pick up in order to predict conceptual difficulty. But conceptual difficulty manifests itself in different ways for different participants, and future research should focus perhaps on what those different factors might be. And with that, I'd like to thank you for your attention and look forward to hearing your questions. If your questions are too difficult and technical for me to answer, you can also mail Aurélie. And there's also a discussion section after this talk. So thank you.
All right, let's thank Rob. We have a question that I will read from Marju Kops. Could the lack of an effect with the blurring manipulation be due to participants?
Dwayne, I can't hear you. Is something wrong with my mic or my?
I think people can hear me.
Yes, I can hear you now.
You can hear me now. Great.
Yeah.
Okay, so the first question, could the lack of an effect with the blurring manipulation be due to participants retrieving the lexical items during the familiarization phase and preparing in advance? What would you expect to see if the familiarization phase was shortened?
Okay, that's an interesting point. So, yeah, it might be the case that familiarization helps them. Although it's important to note that even though they name these objects multiple times in in the pilot study we did before, the norming study with those items, there was still a clear effect on reaction times. So blurring certainly has an effect on what people are doing. It induces a delay in their reaction times, despite this familiarization phase.
All right, our next question is by Brendan Weeks. And Brendan, someone will be unmuting you.
Hello, can you hear me?
Yes.
Very good. Hi, Rob. Thanks so much for your very interesting results. I'm conscious of the fact that in the picture naming literature, it's true that image agreement also controls the way people respond on standard picture naming tasks, so much so it predicts quite a lot of variability in both monolingual and bilingual speakers independent of name agreement. So I'm curious about the point you just mentioned regarding your fuzzy stimuli and how much the image agreement variable might contribute to your results, because clearly your fuzzy stimuli don't map onto the mental representation people hold for the object you're presenting.
Could you elaborate a bit on the question, Brandon? So you're saying image agreement is a strong predictor of picture naming?
Right. So in standard tests of what predicts picture naming in several different languages, the question is how much does the object depicted represent or match your mental representation of that object? That's image agreement.
Right.
It's been used for several decades as a variable in testing what psycholinguistic variables impact upon object and also action naming.
Okay, that's an interesting one. So in the blurry condition, you basically say we create a condition where image agreement is much worse than normally, given that it doesn't match the templates that you would have in your mind, right?
Yeah, that's just my hunch. I mean, I don't know your stimuli, but that would be my expectation, that if it's a blurry stimulus of an object representation, then this could have an impact on the latency. You mentioned there was an effect in your reaction time naming latency data.
Yeah, I agree. That's a great remark. I mean, we didn't consider that variable. I mean, my hunch would be that this variable would still, impact the basic process we're interested in of, conceptualization. So it would still contribute to the process by which it becomes more difficult to find and select your lexical concepts for naming.
Sure, but I think the same argument's made about the image agreement variable in tests of models of picture naming. If you take a look at it's a tiny little literature. It's not well known by many psycholinguists, but it is, Elise Bates was the first to do it. And actually there's been quite a lot of work on Snodgrass and Van der Waart stimuli, for example. But if you take a look at BRM, there's quite a lot of studies that have shown this effect reliably across many different languages. So that's just one suggestion.
Okay, thank you. That's really interesting. I'll have a look at this literature.
Okay.
All right, we have a few more questions here. I'm going to read this question by Irina Sakarina. I have a suggestion on how to replace the blurriness manipulation. How about replacing it with the manipulation of presenting the line drawings of the object with different degrees of visibility using the dashed lines? And this is used in the past with patients with amnesia.
Okay, that's great. That's interesting. Yeah, I mean, it's something we have even considered. There's other work we're aware of that uses these degraded contour manipulations. I think one study was by Meyer and colleagues a few years ago. We've even used it ourselves in one study. So that's certainly a possibility. Yeah, I mean, one reason for using blurriness was to follow in the footsteps, let's say, of Schnatt and Corley, who did show a blurriness effect using English speakers. Yeah.
All right, our next question is by Laurel Brim.
Hi, can you hear me?
Yes.
Excellent. This is really cool. Jesus, sorry, the cat just jumped off my lap. Startled her. Great. So I'm really interested in this sort of approach that you've taken here, where you've got the mixed models and then you've also got this classifier. It's interesting that where you didn't see anything significant in the classifier or in the mixed models, you did see it in the classifier for experiment 2. So I'm wondering what that means about the combinations of cues. So is it on the kind of person level or on the group level, or, you know, if you were to combine multiple types of disfluencies and leave some out, would you start to see signal in the noise in the mixed model data, or is this something kind of unique to the classifier? And yeah, how do we interpret it?
Yeah, well, I guess in the mixed model approach, you usually wouldn't look at multiple disfluencies simultaneously, right? You would predict the occurrence of the particular types as a function of name agreements. So what you do in the classifier is that you combine these disfluencies as cues, but you make a prediction at the individual level. So you make a prediction for one individual's data by combining the data of all the other subjects, basically, a sort of leave one out procedure. And so you get, let's say, parameters for each individual subject. If different subjects are doing different things, then those parameters should start to look similar, right? And that's what you basically see in those graphs. So if there is a significant effect of these individual variables in the MVPA analysis, then that's suggesting that this is consistent at the group level. Right. That's the way at least people interpret this. Yeah.
Cool. Thank you.
Yeah.
All right, I think we have time for one more question. And if I don't get to your question, remember you can take this conversation offline to the discussion board. So Rob, I'm going to read this one and you have to respond in 30 seconds. Got so much time we have left. So this is from Adriana. She says, thank you for the talk. I was wondering to what extent individual differences are related to lexical knowledge. Did you happen to collect some more individual difference characteristics?
30 seconds, huh? Yes, we did. In experiment 2, we have a bunch of neuropsychological tests. And if I remember well, we didn't find any effect of that in the analysis.
All right, very good. Well, that brings us to the end of our session. Let's thank all of our speakers. Quick announcement, so we're going to have a shortened break after this so we can get back on schedule. The next session will start on time at 3 p.m. Eastern. So